All right. Well, everybody, my name is Jersey, and I wanted to bring to you some of my knowledge on measuring equipment and smaller measuring equipment. So I have the three types of calipers and a couple other things. I'm going to put you down, and we're going to go over that. Hopefully, anybody who joins in um, feels free to chat along, ask any questions, and I'll be sure to edit and upload this for later viewing. So there's not very there's not anybody here yet, but a history of the caliper, and the reason they're called vernier calipers is because in 1630, French mathematician, or sorry, 1631, French mathematician Louis Vernier created the idea that if you take the main scale and you add a secondary scale in reference, so this is actually called the vernier scale right here, and this is the main scale, then you can take those two and put them together and use them to measure very small increments. Louis Vernier lived from 1580 to 1637. As I said, a French mathematician. Now, there has been a pair of calipers resembling all the way back to, I think it said, like a shipwreck in Greek. They saw something like that, and that could have been just even more for comparison as well. But to get started and describe the three different kinds, and then I'll get them out of the way. We have a true set of veneer, which is just the scales. We have the next step up, which is a dial caliper, and then we have a digital set of calipers. Now, these all three are 0 to 6 inch, and you can tell that by the max graduation on the main scale. So, as far as that scale goes up, you can see that that's what the max capacity is going to be. Setting these aside, because, well, no, I won't set them aside. Let's start with those first. Uh, these are made by Zeiss, which a lot of us recognize the name if we were to see it on like optical stuff. They make lenses. They do a lot of different stuff. I can't think. Maybe if you were at the eyeglass store, in the industrial world, something like this, which is made out of a non-marring material, is helpful, like for CO2 lasers, the older kind. They use an optical lens. You don't want to scratch. Well, something like this, in piercing, if you go to, and that's why I actually have set out some of my jewelry. If you go to a piercer, they might use something like this. And pretty much the way you read it, and you can see right there, that's 1 1/4. And I'm going to dive much deeper into that, of course, but it's rough right there. And so there is a pair of veneer or vernier calipers because of the main scale and then the vernier scale. You have, oh, hey, cool. I didn't know I could see the messages. Hi, guys. Cool. Leon, hi. All right, I got to pay attention. I was looking at the thing. So you have four main components to every set of calipers, and I just said the two of them, the main scale and the vernier scale. And then you have the jaws. Here you have inner jaws for measuring inner. Here you have jaws for measuring outer. And then the fourth component is the depth stem, as it can be referred to, or the depth gauge. And this comes off the bottom, and it's on the back of the movable jaw with a vernier scale, which is going to be the movable piece on 6 inch calipers. The main scale is going to be connected to the position jaw, the main jaw. So now with that, as I was saying, you can measure, so OD, excuse me, outer dimension there, round and flat, and inner dimension here with the inside jaws. And as far as the depth gauge goes, that is used as a step right there. Oh, 1 second. I got a knock on the door. What up on me? I'm live streaming.
Oh, sorry, but both of the hand towels are missing for some reason.
Oh, yeah. I'll just throw them in the shower if I clean them up. Sorry, I forgot. All right. I'm back. Sorry about that, everybody. I guess I'm not taking my time lapse, so I'll put that away. Veneer calipers are important. I use them literally every day. Uh, in industry, they're used all over, and this isn't the most common pair. The next pair that you're probably a lot more familiar with, or just about anybody has seen, is this pair here. And this is a pair, let me see, this is Brown and Sharp, model 579 stainless steel, 0 to 6 inch dial calipers. And this is this is quite an old pair. They're not repeatable. I cannot certify them. I still have one of the original cases for it. It's pretty bad. But as far as a lesson goes, teaching, they work just fine because the difference, what happened between a vernier set to a dial set is with this, the name is, I apologize, I have a commenter caught me off guard. I'm new to this. The name is How to Use Basic Measuring Tools. So I'm explaining the history of 6 inch calipers, starting with the vernier caliper, dial caliper, and then we have a digital caliper. And I was going to show some tips and tricks. So I hope that answers the question. The name of this live thread is how to use hand tools, or how to use measuring tools, I think. Threw me off guard. All right, so the difference that changed between a vernier set and a dial set is that you had a zero that you could now adjust. When you are able to adjust the zero, you're able to start taking and moving things um, to a set mark and then referencing. So if something were to happen, I can, clean my jaws. And we're just going to set this real quick, and I want to show you a couple of basics. And these ones don't slide. You hear right there. Oh, the mic's here. So right there, there's some catch in the teeth. So I'm going to jump a little bit ahead to the digital pair. And here I have a super old pair. I think this was from the Fab Shop in Muskegon. But Michitoya, I think Digimatics. Yep. And these ones are pretty basic. There's no what I know now as like we call it an LMI port at work, but there's no USB plug-in. There's no interface on these. They're just your regular absolute Digimatic 0 to 6 inch calipers. And with this, you can really see the use of a zeroing function. Oh yeah, this pair doesn't have the set screw, kind of junk. So you would have a set screw right here. This is the set screw. What that does is that it holds it so that when you're doing something, or if you need to use these as a comparison, you can put it at your distance and then set your screw. The best part about having a zero on these digimatic absolutes is, so right here, I'll go to 0. No, I'm a 0. So I need to go to, let me grab one of my coupons here. So this is a 4-inch. A lot of people probably recognize this. I dug this out of my scrap from handrail making days. And, roughly 4-inch by 4-inch by, say, 3/16 or 7 gauge mild steel. And it has a hole pattern for screws, and I would weld the post right here. Well, say I'm the one making this and somebody's asking me, the dimension is I need this, I need X here, and I need X here, and then there's a distance between them and all that stuff, right? So if I'm measuring this and somebody asks me the pitch between the holes, I have a couple different things I can do. Well, if I want the center line, I can measure here, and then I can do that. The more accurate way would be measuring this hole, dividing it by 2, measuring this hole, dividing it by 2, and then grabbing this. Now that would give you, oh, there's also the old school way where you just eyeball it like that. But we don't eyeball stuff. So the neat part, and one of the tips and tricks about the digimatic calipers is if I go here and I just zero it out on a hole diameter, I can now measure across both and get my center. Oh, well, that's not inches. Let me reset these. Or maybe it's the other way, and then I go in. Let's see. Again, that's why I'm doing this live, is because my practice, and I'm not doing very good because I'm sitting behind the camera and I'm just watching the camera when I should be watching my hands do the measurements like I'm teaching. Okay, yeah, that's way better if I just sit down here. Right here, I can't really, I can't really see the thing. But so, what was I doing? It's way better. All right, so I'm going to zero it out. I'm going to close them. I'm in millimeters right now, and I want to be in inches. So I'm going to go to inches. And right there, sits, it's repeatable. And I'm 4 place decimal. So I'm going to do the quick math of it. This hole is 3/8, 0.375. But it's laser cut, so it's a little bit bigger. The spread is 2.61, 2 and 9/16. So 2 and 9/16 plus 3/8 is, that would get you, no, it'd be, so what you would do is you would measure all the way across, and then you would subtract 1 hole diameter, and that would give you your center line to center line. So you're looking here. Units, I just switched to inches. I can do both, metric or not. I don't know why I keep saying I do mostly, so being I'm in Michigan, so American, I'm mostly familiar with the imperialist, but metric, a lot of the machines I've worked on are from Sweden and across the world, and everything there is metric. So I am very familiar metric. The reason I put this into inches to measure this plate is because I just know this plate was laser cut. At what shop it was laser cut, I made it, and the units is inches. So right here you have inches and millimeters. Yeah, let me start over. Let's go back up to so you have the jaws for measuring OD, jaws for measuring ID, your depth stem for measuring steps, and the main scale. And this would be now the vernier scale. So the dial was taken over by that LCD readout, and the dial itself took over for that right there. So there's the evolution of the 0 to 6 inch scale. So from here to here, now that I'm sitting better and I can show you in inches, I want to know the center line. Well, real quick, let's just eyeball, so I don't got to do much math. That's a 3 inch center. Well, if I take and I have a digital pair of calipers and I zero this out, right? I'm like, all right, there's a hole. Zero it out. And then now I go all the way across. What do I get? I get 3 inches. You don't have to do any math. If you're looking for a certain center line and you know, because you're the dude who laser cut it, that all your holes are, oopsie, I'm getting ahead of myself. So now, you know all your holes are on average the same thing. These are all running about 10 thousandths big. I can take, and when I get to a center and pull it out and zero it out, now that I reset my zero, I can go through this plate and say 3 inches. 3 inches. 3 inches. And that 3 inches represents my center line. And I didn't have to do any math. That's my first tips and tricks about using a digipair. So back to just the simple form and function, because that's what I want anybody watching to walk away from. I want, somebody who's maybe just fresh out of high school, didn't have industrial arts or something, and they're trying to go get a job at a million places. This is the same. And I have set out here, I haven't even gotten to them yet. I have an old Draftsman ruler. I have a 6-inch scale with a sheet metal hook at the end. I have a Brown and Sharp 0 to 6-inch scale, and then an SPI, I believe, stainless steel bore gauge, which that is super sweet, because if I wanted to measure the depth of this hole, or what would be a bore in something, I drop it in, and then that, let me see if I can get this, tells me what my hole is. So I measured 3/8 with those earlier, right? And I can use that. And then I see a comment. So yeah, digital is going to be easier to read, but for the 5-place decimal, I can't go down to a 5-place decimal with dial calipers, but you can get actually really close with some of the graduated scales on these. But this one only goes to, and right there it says this one only goes to a 3-place decimal. So this pair is 1, 2, 3, is one more decimal place more accurate than this. So you 100% correct in that comment. This is and should be more accurate. And so there you go. But there's a few other features I wanted to make sure I pointed out. Working on a shop floor my entire life, I'm going on like 24 years, it's important to know how to use the tool in different situations. Of course, ID, but if you look, you have a bevel, you have a point, you have, a little curve. All of these things aren't just made up, right? And this one has a broken tip. All of these things were made so that when you're measuring different features of sizes, you can get in. And I'm not going to measure an arc to arc like that on the flat. That flat could be there, but I want one point of singularity as I'm measuring. So I'm going to measure that, and there's 1 inch. I'm within half a thou, a one of 0.95 inches right there. And then here's OD. And this is just a slug I found on the ground riding my bike past the shop. All right, there's that. Um, the cool thing, a lot of people don't realize, and I'm kind of not perfectly set up for it, but uh, underneath right here is from this to this. Because this moves, it's the same as your depth stem moving with it, except your main scale now can become. So if I had a line, imagine that line is whatever, I can come here and use that step. And as long as I know I'm flat and I feel it and I'm square to the world, I can use that step and it goes right along. So there's a neat feature. The depth gauge right here is used in the sense if I need to do something like that, I can come in, touch it, 0.442. So probably, somebody's aiming for a half-inch step. This is all just stuff I grabbed out of the bottom of my toolbox to give examples, but the examples are just the basics of it. Anytime you get into a situation, and if you're familiar with how this tool works, ID, OD, depth, and you're familiar with the concept of keeping your jaws clean and keeping everything squared to the world. See, like right there, I got to come up, but I'm not going to go up too far and get all kittywampus. You want to take a nice, clean, smooth measurement. And the biggest part about using measuring tools like this is that it should be repeatable. So a digital pair of calipers is super nice and capable of more accuracy, but a lot of the times there's absolutely nothing wrong if you have a repeatable pair. This tool right here, if taken care of, will last 100 years. Well, if, I don't want to get into that because now it's going to be a fight about how long they last. Like they last a long time, okay, and that's all I'm getting. And then a sheet metal depth is that if I was reaching in somewhere and I needed to pull back, I can see that that's a 4-inch plate. And on the rule, I have one side that's imperial. They both are. So this has no metric, but without so just in standard, a ruler, it's about the graduations. So this scale here goes down to increments of eighths. So that's 16ths. This one, and it'll always say, so right there says that that's the increments of 64ths. And I know you can't see it very well. Oh, check this out. I do have this. I didn't know if this might help people see or not, if I could get it to work. So right in there. Yeah, I don't think that'll work. But so you have 64ths, so that'd probably be 30 seconds, 16ths, and then eighths. And that's the what the scale, and it's just so shiny. And that's the increments the scale is broken down to. Now, those all coincide to fractions. Fractions coincide to decimals. And decimals is where you can convert to metric. So if there is 2.54 centimeters in an inch and 1 inch, then your conversion rate is 25.4 or 2.45. No, 25.4. Yeah. So 0.375. Let's try this. I'm getting way ahead of myself here. All right, so 0.375 times 25.4 is I don't know, man. I'm recording on my phone. Oh, but the easiest way to look at it is if you get close to the tenths. So one thousandth. Oh no, not the tenth. I apologize. 1 millimeter is roughly 40 thousandths. It's 0.039. So 1 millimeter equals 0.040 in my head. Thousandths to me, 0.125 is an eighth inch. um, 0.5, half inch, 0.375, 3/8, right? So you start to learn these, and as you get comfortable and you kind of work backwards. So when I was young, my first shop class in high school, the very first thing we did is he had a paper and it had pictures of tire tread, right? And it had tire tread and it had a picture of this, but it was hidden. And it would say, how deep is that? Well, and it's like you had to, and you had to look back, but you had to see how it was because, well, if I know there's 8/8 in an inch and there's five showing, then three are gone, right? So I'm 3/8 of an inch in. So starting with that, and if you can hear my voice, I get passionate about that because I was 14 and it was awesome getting into the trades. So when you when you start to see that and then you start to learn, so an eighth inch just goes to sixteenths. What's half of a 16th? A 32nd. What's half of a 32nd? A 64th. Half of a 64th. 128th. And I've never really had to go that far, but that is what's so cool is if I know, right? So my tip, all of the tools on the press brakes I used to work on were 1 millimeter. So that's about 40 thousandths. So if 1 millimeter is about 40 thousandths and an eighth of an inch is 0.125, then 3 millimeters is about an eighth of an inch. If you can learn that, okay, so now I'm starting to see 4, 8, 12, 120, you know. So for me, it's been over the years of visualization and then you can even go further. So if that's 3, so 4 times 4 is 16. So 4 millimeters is 0.160. Well, 0.1675 is 3/16. So now I've went from millimeters to decimal to fraction in my head. And I'm not saying I can do this all the way up the scale, but when you're a laser technician or you're working on a press brake, and you just need to go about, like, if I grab a standard set of Allen wrenches and it's a little loose, then or then I know it's the next size and metric, or vice versa, anything like that. So I wasn't I apologize, I wasn't ready to like write and do all this stuff. I totally should have been. Um, and I can confuse you even more. 9.6 something, thank you. I can confuse you even more because this, um, oh no, it's not confusing. This is the better of the one. So here's the 64ths of an inch and then the metric equivalent. So 10, so 25.4 inches is equal to 10 millimeters. And you can see that right here, that between 25 and 26. So if I have 17 64s, it's going to be equivalent to 6.747. And the reason they do that for the 64s is because metric gets down to such a smaller decimal place. So like right there, You can't read these anywhere else. This is obviously not 1 inch, but 64, 7 inch is equal to 25.4 millimeters. And if you can start to wrap your head around some of that, and so here's on this side, let's see, does it have both? Yep. So the reason they give you that is because here's the side with 64ths, and then here's the metric side. And so this is both, and it gives you some information. Now, this one, the bore gauge, has fractions, and it looks like, now I'm not the best at these. That's the previous answer. Oh man, maybe there's a. So it says 1/64 increments right there. But then it's 5/8, so half inch. Oh wow, because look at it, it's not a linear scale. So each one of these lines is a 64th of an inch. So if I have this and I have this, then I can convert, right? These two things right here, shop rats. Dude, if you're out on the shop floor, get these. You can, from here, get to here. Here, you can do holes. You can get back and forth. That's awesome. And then this one is, again, with the hook, that's the 0. So that you're behind. When I hook something like this right here, I grabbed a piece of unistrut from downstairs. If I take this and I can't see, right, but I know I want to grab that edge, I can grab that and say, all right, I'm between 4 and 5. I'm under 4.5. I'm under 4 1/4, but I don't see 4. And I see 4 and 3/16 and 1/8 and 1/16. So that's somewhere between 4 and 4 1/16. Or right here, you can get a little bit easier and see it's just behind it. So that's how I use that. The unistrut, I grabbed this also because it has round slots, so you can, and that is one way. And see right there, you don't want to measure around like that, go like that. So that, yeah, that's it. There's been talking for 32 minutes. I appreciate everybody who's joined in. This has been a rambling mess. But that is the history. There's the history of calipers. There's some conversion rates. Carry around a little notebook. And honestly, I hope, and I'll end with this, outside, inside, and depth. Created by Pierre Veneer. Yeah, there is. Yep, there is error. And so created by. Sorry about that. My ADD, you guys, is amazing. Pierre Veneer, 1580 to 1637. He put these in use in 1631. He was a French mathematician. And that, thank you everybody for coming and measuring stuff with me. Oh, yeah, look at this. This is my. So I didn't Google it. There's a couple different things, but does anybody know what this? I'm pretty sure that's for the draftsman table, the little line there, so that when you move with your draftsman wire, you move up and down. But and then that one, this is only one-sided and it has the slant. And that's just standard, but see, it doesn't start at 0 as a thing. So you can't, that's not butting it up to anything. This is just for drawing. Oh, and then while we're at it, because I already did a little video about a tape measure, here's a tape measure. And because I live in both worlds, in my head, I have a metric and standard tape measure. And the difference in that slop, everybody talks about that slop, that's ID. Well, ID when you push it inside of a hole, right? Like, so there's a difference here. See, when I pull, it's going to say, and it's a little slack, 4 inches. But if I were to be ID and I needed to push that, I would get 4 inches because that slack compensates for the thickness of your hook. And if you have a mag hook, always remember to clear off all of your measuring implements. Always remember to clear off anything before you do it. Now, I was taught by the old guys that you use your skin, or if you have your shirt or a piece of fabric, I have, because I do video stuff right in front of me, you can just close them up on the fabric and then pull it off. That'll get it. Uh, be careful as you use your tools because there is steel that they can become magnetized. So a demagnetizer is nice to have for some of this. And there it is. There it is. Oops. Thank you everybody for joining me. I was gonna do 30. Okay, holy cow, I'm at 36 minutes. All right. Hey, I'm gonna take you down from here. All right. I appreciate every single person who joined in. If anybody has any more ideas or topics that I can explain about in the world of fabrication or skilled trade, science, technology, engineering, math, let me know. This is how I wanted to use my time off at home resting today, is spreading some knowledge. So I hope everybody enjoyed, and peace.